All right, welcome to The Explainer. Today, we're diving into something that's, well, it's pretty critical, but it's a threat most of us never even see. We're talking about the invisible war being fought over our energy supply.
So let's kick things off with a pretty big question. What if someone, somewhere, could just turn off the world? It sounds simple, right? But the answers are, well, they're complicated and, honestly, a little bit scary. And look, this isn't some sci-fi movie plot. I mean, think about it. Everything in our modern world, from the streetlight on your corner to the entire global stock market, it all runs on this massive, interconnected, and more digital power grid.
Okay, so to really get our heads around the danger here, we've got to first understand what's actually being targeted. Let's talk about this hyper-connected power grid.
You know, the energy sector is the absolute backbone of, well, everything. And right now, it's going through this huge digital revolution. Companies are grabbing all this new tech to be smarter and more efficient. But here's the flip side. Every single new gadget, every new connection is like installing a brand new door on a fortress. And for an attacker, that's just another potential way in.
And this is the part that really matters. If the power goes out, it's not just about the lights going dark. It's a massive domino effect. Seriously, hospitals go on backup power, but for how long? Water purification plants stop, communication networks fail. Pretty much every other essential service we depend on, it all grinds to a halt without power. So who's actually doing this? Who are the players in this invisible war? Let's take a look at the new rogues gallery. Yeah, the folks trying to mess with our power grid, they're not just one type of villain. We can actually break them down into a few key groups, and each one has a totally different reason for doing what they do. Okay, so check this out. The range here is pretty wild. On one end, you've got state actors. We're talking nation-states with huge resources, playing the long game, focused on espionage and sabotage. Then, you've got your cybercriminals, right? They're just in it for the cash, using things like ransomware to get a quick payday. And then there are terrorists who want to cause physical harm and hacktivists making a political point. But here's what's really getting scary. The lines are blurring. You might have a state actor hiring a criminal group to do their dirty work. That creates this hybrid threat that's super dangerous and really hard to predict. And the weapons they use? Just as varied. They've got everything from these super sneaky long-term hacks called Advanced Persistent Threats, or APTs. Think of them as digital spies living inside a network for months, even years. Then you have the total opposite, brute force DDoS attacks, which is basically just flooding a system with so much traffic it just collapses. And it's not just software we're talking about. People are now physically implanting malicious hardware. That's a whole other level of threat. So, okay, this all begs a really big question, right? If our power grid is this important, why on earth is it so vulnerable? This image right here, it just perfectly sums up the problem. On one side, you've got this massive physical industrial stuff, power plants, transmission lines, you name it. And on the other, the complex digital systems that now control it all. We've basically plugged the real world directly into the internet, creating what's called a cyber-physical system. And trying to secure that, it's an unbelievably huge challenge. And the scale of it all is just mind-boggling. We're not talking about protecting one single thing called the grid. As this report points out, the North American system alone has over 200,000 miles of transmission lines. And get this, more than 1,800 different companies own and operate pieces of it. 1,800. They're all connected, but they all have their own security standards. And you know what they say, a chain is only as strong as its weakest link. Okay, here's another huge problem. Think of a company having a front office and a back room, the factory floor. There used to be a thick wall between them. The office computers, that's IT, information technology, were separate from the machinery controls, that's OT or operational technology. Well, that wall has basically been knocked down. Now, the network that runs your email is connected to the system that controls a massive turbine. So a simple phishing attack on an office worker could literally become a direct path for a hacker to take control of critical physical equipment. It's a huge vulnerability. And if that wasn't enough, the number of potential targets, what we call the attack surface, is just exploding. We're adding millions and millions of new Internet of Things, or IoT devices to the grid, things like smart sensors, smart meters, all of it. The market for this stuff is set to grow fivefold in just 5 years. And every single one of those little devices is a new potential doorway for an attack. So here's the real kicker. It's the root of the problem, really.
We're putting all this shiny, new, hyper-connected technology on top of a foundation that was built decades ago. It's like trying to run the latest smartphone software on a computer from the 90s. These older legacy systems that still control critical equipment were never, ever designed to be connected to the internet. Cybersecurity just wasn't a thing back then.
All right, so what actually happens when an attacker finds one of these weak spots and gets through? What's the real-world cost of a successful attack? Well, it's definitely not just the lights going out. It's a cascade. A single attack can trigger a wave of failures that spreads through every part of our lives, causing physical damage, massive financial losses, political chaos, and just total societal disruption. And look, we're not talking about what-ifs here. This stuff has already happened. We saw widespread blackouts in Ukraine caused by a cyber attack. The financial hit can be in the billions of dollars when you factor in downtime and repairs. Internationally, it ratchets up tension between countries, and for all of us, it means work stops, travel gets chaotic, communication breaks down, our whole way of life gets turned upside down. Okay, so the threats might be invisible, but that doesn't mean we're helpless. They're not unbeatable. So let's switch gears and look at how we can actually start to fight back and see these invisible threats.
One of the coolest new ideas out there is something called a cyber digital twin, or CDT. The main goal here is to solve that hardware visibility problem we talked about. How do you know what's really plugged into your network? Well, this tech creates a unique digital fingerprint for every single piece of hardware just by looking at its one-of-a-kind electrical signature. It's pretty genius.
And the way it works is actually pretty straightforward, but it's super powerful. Step 1, it scans that unique electrical signal from any device trying to connect. Step 2, it compares that fingerprint against a trusted list of devices that are supposed to be there. And step 3, the most important part, if a device isn't on the list, if it's a fake or if it's known to be malicious, it's just blocked instantly. It can't even get on the network. What this does is give security teams the one thing they've been desperate for: total, complete visibility. It lets them see and control every single device, whether it's in the office, on the factory floor, or a tiny sensor out in the field. It basically slams the door shut on those hardware blind spots that hackers love to sneak through. Which kind of brings us full circle, back to a fundamental question for our time. As our world gets smarter and more connected, is it also becoming more fragile? The very tech that's building our future seems to be creating its biggest weak points. So we really have to ask ourselves, how do we build a future that isn't just smart, but is also strong and secure?